Hello and thank you. Today we'll talk about propagation. My name is Kevin Rice and I'm from Crown City, Ohio. I'm the Basic Science Division Director for the Center for Diagnostic Nanosystems at Marshall University. The topic we will look at today is the concept of sound propagation. Sound waves are mechanical waves. Sound waves are oscillations of pressure. This pressure is transmitted through a medium. This transmission of pressure is known as propagation. Sound wave pressure can propagate through compressible media. Such types of compressible media include air, water, solids, and plasma. Sound cannot travel through a vacuum. It needs some sort of media to propagate the sound's pressure wave. Media effects on propagation include the density of the media, which alters the way in which the sound wave propagation occurs. Media with greater densities slow the propagation of the sound wave. Media with lower densities allow the sound wave to travel faster through them. This is the reason higher altitude affects the sound propagation, the sound due to the lower density of the air at the higher altitudes. Media which does not have a constant physical property may refract the sound wave propagation, either through dispersion or focusing. Such materials are used in soundproofing. Additional considerations. Viscosity of the media will alter the motion of the sound wave. Sound propagation through water, low viscosity, will be faster than through oil, which has a higher viscosity. Motion of the media can also alter the propagation of sound waves. Sound carried on the wind will alter its propagation. In the direction that the wind is moving, you'll hear the sound propagated faster towards you, but in the opposite direction of the wind direction, you'll not be able to hear it as soon, and that alters your spatial orientation in an environment. Temperature can alter the propagation of the sound wave, and this is due to the fact that molecules that are at a higher temperature have a faster kinetics. So the kinetics of the particles then alter the propagation of the signal, the propagation of the sound pressure. Humidity can also alter propagation. Humidity also alters the density of the air, and these elevations in humidity will actually make the sound wave travel a little slower. Now these are mathematical calculations, and in most instances you won't be able to hear them, but they do have an effect on sound propagation. The wave propagation through solids. This table describes the ways in which sound waves can be transformed to carry these propagations of sound waves through this solid. There's longitudinal, transverse, and these are shear. And the wave vibration, particle vibration, occurs in different orientations through the media. And so with longitudinal, the wave is parallel to the wave direction, and transverse, it's perpendicular to the wave direction. In some instances, it's just along the surface of the solid, and these alterations in the way that the signal, the wave type, is transformed and allowing the propagation of that signal through the surface can result in a number of different things. So sound propagation in solids, so the speed of sound, the sound pressure propagation, that is altered as a fundamental property of the material. It's the shape, or it is the square root of the ratio of the elastic modulus, which is the stiffness, to the density of the media. Sound propagation through solids can generate anharmonics. These are affected by the sound amplitude. So the greater the amplitude of the sound pressure, the sound wave, the probability of anharmonics forming on the solids is greater. And these anharmonics can generate nonlinear propagations. And these nonlinear propagations can result in harmonics and mixed tones not present in the original sound. So wave propagation is required to transmit sound from the sound generation to the human ear. And the human ear has its own mechanism for propagating the signal into the neuronal sensor that is found in the cilia area of the ear. And media affects the sound propagation. Thus, the use of various medias in the creation of instruments gives them unique sounds and also different tonal qualities. Those anharmonics that we were mentioning earlier can be found based on the type of material that is used in the instruments. That's why one guitar will sound different than the other because of the type of wood that is used, and it gives it a different tonal quality, a different set of anharmonics and harmonics that are present in that instrument. The transformation of the sound through the media can take many shapes and have various effects. Understanding these effects is essential to understanding how sound is propagated. Thank you for your time.